Hey, everybody, this is Larry. This is day 13 of the November Leetcode Daily Challenge. Hit the like button, hit the subscribe button. Join me on Discord where a bunch of smarty pants, smarty people post their solutions every day to get, feedback or just like to share and all that stuff. Anyway, okay, so let's see. Given it an array of interest temperatures represent the daily temperature. Today's problem is the daily temperatures, but what does that mean? Such that number of days you have to wait after ith day to get a warmer temperature. Okay. So problems like this, and if you've done enough problems like this, you'll probably have some intuition about it. I'm gonna solve this in a couple of ways. Because this is Friday evening here, and I have a little bit more time than I do usually. But I'm gonna have a video to mono Q, and I know that's a hint already. But I think the key part about these problems is not necessarily like memorizing or even knowing these quote unquote data structures or pseudo data structures. It's about asking yourself, what question am I asking at every moment in time, and then how can we make a transition between answering one query and then another query, right? In this case, and maybe in other cases, and some of this will require practice and thinking about it, obviously, and stuff like that. But from here, the n squared solution is very easy. This is 10 to the fifth, so n squared is not going to be fast enough. Though, another thing to kind of think about is that, and this is the first thing that came to my mind, is that or at least not necessarily the first thing that came to my mind because it's correct, but the first thing that comes to my mind as something to think about is, can we do it backwards? Or rather, is it easier if we go backwards, right? Right here, like one way that we can say is that, okay, given some number or some index I, we have to find some index j, right? What if we go backwards from right to left and then process them in every way? And here, that's where I think that's where experience and practice and stuff like that comes in, but it also gives you an idea of what kind of queries that you have to keep going. And because we're going from right to left, the way that I do it, just for a bit laziness to be honest, is that I am going to maybe I could reverse and go left to right, but maybe it's not that big of a deal. And I have to see whether it's strictly warmer, but number of days. Okay, so let's think about the problem together, right? Let's say now we're going from right to left, and we'll work with an example first. I know how to do this now, just thinking about it, but just to go over it. Okay, let's be clear again that we're going from right to left. So let's put the pointer at 73. So to 73, the answer is going to be 0 because you can't go from. There's no warmer temperature. Yeah, it's 0, right? And then 76. Well, what does 76 mean, right? Well, 76 means that everything to the right. Let's just say we keep track of everything to the right, let's say we keep track of the max number. An idea of that. Okay, something that's to the right, that's max and also closest, right? So those are the two things that we're thinking about, and initially that's going to be 73 as we move to the 76, and then 76 we go, okay, well, we know that looking at this thing that 76 is the max, 73 is the max number to the right of 76, and therefore 76 cannot have a possible answer because, well, everything to that is, and then now the thing to think about is, okay, the thing to think about is this transition, right? So 72, we're asking the same question, but then now, for example, if you naively, you may implement something like this where this is to the right of this, but now we want to say, like, basically this is just a suffix. That's all I'm saying. So when we go 69, it'll have 72, and then here when we go to 71, we have 69 and so forth, right? ... So that's basically the suffix, and if you do it naively in a for I for j loop, that's what's going to essentially happen, right? You just go to the next one that's bigger. The question is, from this suffix, is there anything that what we call an invariant, something that doesn't change as we go from right to left, right? And the idea is that, okay, let's step back for a second. Let's go back to 72, right? At 72, what happens when we have this suffix, right? Well, if you, and this is just to build up intuition, where if you do from I to J, well, what happens is that no matter what, so I mean we have 72 here, but no matter what number for any x, right? So what can we say about x? Let's say x is from between 0. Oops. Let's say for some x, we don't know the input yet, even though we know it's 72, but let's say we have some number x, right? And it's within 0 to 100, because I think that's it's from 0 to 100, but same idea. So there are only, if you think about it, there are only 3 scenarios, right? So we break this down, we go, okay. And this is the way that I would think about proving it until you're more comfortable with, skipping some steps because you're doing it a lot. Is that, okay, so x can be less than 73, right? If it's less than 73, what's the answer? Well, it's 76, right? 76 is the answer. If x is greater than 73, and less than 76, right? Yeah. What's the answer? Or maybe less than strictly in this case. I mean, this is a little bit off by 1 potential, but just bear with me for a second. I don't think for this problem it matters, but this is just for visualization, right? Well, if x is between 73 and 76, then in that case the answer is 76, right? So yeah. And then now, what is the case with x is it's greater than 76? Well, in that case, the answer is 0 or infinity, depending on how you want to define it. So then now we are breaking it down to 2 cases where, okay, if x is less than 76, the answer is 76. If x is greater than 76, or I guess this is equal as well. No, sorry. If this is equal to 76, then the answer is 0, right? That what this tells me is that 73 will never be the answer again. So that way we just go from left to right and we go, okay, because 73 is smaller than 76, 73 can never be the answer. So we remove it. And then now we have 72, right? Like now we want to consider 72 as a possible answer. Well, we do the same thing, right? So we have 3 scenarios for the next number, in this case 69, but we'll ignore the 69 for now. So x can be less than 72. And in that case, the answer is 72. If x is, wrong notation. If this is x, then the answer is 76. If x is greater than 76 or equal to, then the answer is again 0, right? So that means that, okay, so we have to consider these cases and we'll think about it, right? And then you kind of iteratively do it again, and then now the next number is 69. So we know that 69, the answer is 72, so we put in the answer, and then now we think about it, right? And note that, and then now you have some x, and then you kind of break it again, and then you'll notice that, you come from right to left, and then you kind of break it down. But one thing to notice is that now, let's say the next number is 71, right? If you kind of do that brute force thing again, you'll notice that no answer, 69 could never be a possible answer, and that's why we remove it. And once you kind of practice this kind of intuition, really brute force kind of way, you'll see that, and note that we never think, or I never said that this is monotonically increasing, though that is a monotonically increasing stack. And that is just because, for me, I always say that this is an emergent property of the things that we're doing, of the invariant. It is not, we're not taking advantage of the monotonicity. It is just something that, because of the invariant that we created, it came about, right? That it happens to be that way. So make sure that you get the cause and effect maybe more correct, will allow you to kind of visualize this in a different way. Because I think one thing that I've noticed, and this may not be you, but one thing I've noticed that happens frequently is that people start with this idea of a monostack, and then they try to figure, okay, this is a monostack problem. I'm trying to come out at it with a monostack. How do I make this monostack work, right? And I think that's the wrong direction to approach it from. I think in general, and to be honest, this is why I think up until recently, people didn't really call this mono stack. I think this is just a regular stack problem when I was younger. But as a result, I don't know why people inventing names for everything. Maybe it's easier, but I think in this case it adds some confusion because it doesn't really come up. Like I could describe this entire solution without noting that it's monotonically increasing. It's just that way. And yeah, and I actually don't really remember it. Like I'm not at the point where I'm like, oh, this is just a monotonically increasing stack problem, right? Because I actually don't remember it. What I remember is that, we're always trying to get the next number that's bigger. And then what I showed you kind of, but in a faster way, I go, okay, if this is the case, we pop something off and then it turns out that this is a monotonically increasing stack, but it doesn't matter. Anyway, so that all that said, we can get started on implementing, right? So yeah, so let's say n is equal to length of the temperature. And then now let's start with stack. And then now we start for j is from the last element. It's always a little bit awkward in Python, this for loop. And then now we need an answer array. And the stack is, I'm going to make a variation of the stack because for this problem we need to know the number of days, and you only know the number of days by keeping track of the indexes. I'll show you in a second, but the idea that I explained still holds. It's just very minor differences. So yeah, so if length of stack is equal to 0, I like doing it this way. Maybe you can think about another way of writing this, but I would append temperatures sub j and also the index, which is j, right? And then for here we append 0 because there's no answer. Otherwise what do we do? Okay, so then we look at the top of the stack, and here we know that on the top of the stack, if it is bigger than the current number, that's going to be the closest index, right? So but if it's not bigger, then like we said, if it is not bigger, then we know that answer cannot be any answer to the left of the current index. So then we can remove it. So we can do while length of stack is greater than 0. And actually, I guess we can actually refactor this in a second. But I like to kind of start off this way so I can break off the cases and then do your refactors a little bit later and optimize a little bit later. Yeah. So while stack is greater than 0. And stack of, I guess the last element, the first element of the top. If this is less than or equal to, I'm trying to think whether the equal to part makes sense. Because of off by 1. So if it's equal to, then it's not the answer for this current one. So yeah, then we stack that pop. And then now at the end, I guess now I know that I can do this because I think that's invariant. So then now if the stack is equal to 0, then we do this. Otherwise, we know that that means that now stack is greater than temperatures. So then now the index, which is the number of days, I may be off by 1 here, but it should be mostly right, which is so j is the current day, and the previous day is stack. Maybe I'm off by 1 here potentially, but that's the answer. And then we want to append stack, which we know in the invariant that this is smaller than the top of the stack. This thing again. So actually, yeah. So then here you can see that actually we can refactor this to do this. Yeah, and actually I think I messed up because this should come before here, otherwise this will be 0. But so I'm glad that we made that thing. But yeah, I wasn't careful about that. Oh yeah, and this is the answer, but it'll be backwards, so then now we just have to reverse it. Yeah. Give it a run, let's give it a spin. It looks good. I think the only thing that I would think about is maybe one, like a case with one number. Knowing that this is linear time, I don't really have to test the big case because linear is linear time, and you could see that this is linear time very easily, and that this is a linear thing, and also linear space. And that you can't do better than linear space because of this answer array, but we also use linear extra space. Outside of that, how did I get a time limit here? Yeah, sounds good. This is way slower than the. Maybe they added more test cases. Well, it's been 2 years, so I imagine they added more test cases. Cause this code is pretty much the same-ish. Cause the other thing that why I know is I'm guessing that they add test cases is because if you look at this is linear time, and I don't think we do that much expensive things unless I'm really messed up somewhere. Where is this time limit exceeded? Oh, I tried the binary search one first. That's interesting. Anyway, yeah, so this is linear time because you go through the array once, and like I said, linear space because of the stack and answer. This problem is very prone. I wouldn't say it's very likely, but if it shows up on an interview, I would not be surprised. So I definitely would practice these problems. I mean, this just requires knowledge of stack and also the understanding of invariant, and try to figure out the logic as you kind of make transitions. So I would definitely practice this and other stack problems. That's all I have for this one. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord. Have a great weekend. Have a great Friday. Have a great everything. Stay good, stay healthy, to good mental health. I will see you later. Bye-bye.